Hey everybody, I wanted to make sure that I went through and actually gave you solutions to the practice quiz that you took a couple days ago. So we're just going to jump in and take a look at the vocabulary here. So first of all, I've got the words at the bottom. It might be helpful if I have them up at the top of the test. I'll figure that out, or on the quiz, and I'll figure that out later. But so the amount of distance that light travels in 1 year, that is actually the definition of a light year, which is choice C. The average distance from the Earth to the Sun, there's a little bit of variation in that distance. We're going to learn about that when we get into Kepler's laws and how planets orbit stars, and also how moons orbit planets. But the average distance from the Earth to the Sun is about 93 million miles, and that is our standard astronomical unit. Now, this word here was a bit convoluted in that it's not how we actually think of this word. Named after the ancient Greek word for wanderers, because these objects move quickly across the celestial sphere and appear to move backwards at certain times. So that's what they do, and that was actually why we came up with the word planet to describe them. It was related to the ancient Greek word for wandering, because they appeared to sort of wander across the sky, unlike the more or less fixed background of further away stars. The phenomena that distant objects seem to be in different locations when viewed from different positions. And I want to be really clear, this is that idea that you're looking at something far away and or something relatively, you close one eye, you close the other, and you look at it. That's known as parallax. I'll actually give you a better definition in the study guide, but that's a good operational one. Now, the imaginary sphere that surrounds the Earth, where all the stars, planets, galaxies appeared alive when viewed from Earth. So we sort of think of the Earth as being surrounded by this is not in real life, of course. This is sort of our imagination. Like when you go to a planetarium, it's a domed ceiling, and then they just project the stars and galaxies up there for us to look at. And we sort of pretend, or that's the model that we use for the sky when we're looking at things from the Earth's perspective. That's the celestial sphere. Now, the apparent backward motion of planets, you can almost stop right there. Backward motion of planets, that's really the key phrase there. What we're talking about there is retrograde motion. This is actually the definition of retrograde motion for planets. I already talked about the fact that this distance is equivalent to about this much. That is the astronomical unit. Now, this other gigantic distance, about 6 trillion miles, that is a light year. And just to be clear, that is the distance light travels in 1 year. This, meaning the term, I can use this concept or idea to calculate distances to nearby stars based on the fact that they seem to shift their positions in the sky as Earth goes around the sun. By the way, there's a little drawing of this later on. Right here on part 4, I actually have that in the practice quiz. So what you may notice is with some of this vocabulary, I leave even in the very problems themselves, there are clues to the vocabulary. This is, again, parallax. Okay. And then finally, the 3 laws that describe the motion of planets around the sun, that is Kepler's laws. I wanted to do some math around it this time, but I think just given the fact we get started on this planets project and are building the websites, I think I'll hold off on the math part and we'll save that for the next unit as we look at solar systems, planets, and how they work.